We'll be solving Leetcode 2463 problem. The problem name is minimum total distance traveled. So what the question is saying, first of all, it is a hard level question of Leetcode. So let's see what the question is saying. So question says that there are some robots and factories on x-axis. So basically there is a x-axis and which contains various factories and some robots and like this. Okay, so there can be multiple factories and there can be multiple robots like these. Okay, uh, so, and on the x-axis, you are given an integer array robot where robot I is the position of the ith robot. Basically, we are given a array of robots which is denotes the position of the robot. Similarly, we are also given a 2D matrix 2D matrix of factories which denotes the position and limit, indicating the position of the factory and how many robots it can repair. So it's denotes the limit of the factory. Basically, we are given 2D matrix which represents the position of the ith factory and its limit. The position of each robot are unique. The position of each factories are also unique. So basically, both the position of factories and robots are unique. So basically, they are not overlapping. Note that the robot can be in the same position as the factory initially. Basically, robot and the factory can be at a particular position, at a particular initial position, because like the same position. All the robots are initially broken, so basically all the robots are broken and they keep moving in one direction. The direction could be negative or positive direction of the x-axis. When a robot reaches a factory that does not reach the limit, the factory repairs the robot and it stops moving. At any moment, you can set the initial direction of moving for some robot. Your target is to minimize the total distance traveled by all the robots. Return the minimum total distance traveled by all the robots. The test case are generated such that all the robots can be repaired. Okay, so let's see what is the note. All the robots move at the same direction. No, all the robots move at the same speed. If two robots move in the same direction, they will not collide. If two robots move in opposite direction, they meet at some point and they does not collide. They cross each other. If a robot passes a factory that reaches its limit, it crosses it, and if it does not exist, if the robot moves from position X to position Y, the distance it moved is the modulus of pi minus X. So let's see this with an example. So I will draw it. So this is the question given to us. So this is the question. Basically, this is my x-axis, this is my robot, this is my robot, and this is my robot, and this is my factory, and this is my factory. And the limit of each factory is 2, 2, which signifies that only 2 robots can be repaired at each factories. What is the position of the of the robots? It is 0 position, it is 4 position, it is 6 position. Okay, for the factories it is at second position, it is at 6th position also. Okay, so let me mark the position as green. So these are the position given. Okay, now we need to find we need to find is the minimum distance traveled by the robots such that all the robots are repaired. So first of all, what we'll do is first of all we'll sort the array according to the according to the increasing order. Okay, both the robots and the factories. So I have sorted it, so it will come over here, it will come over here, and the factories is over here only. And I will divide the factories into multiple parts, so basically based on the limits. So in this case there is one factory over one factory over here which has a limit 2, so I will break it down into multiple factories with a limit 1. So what is the limit of the current factory is 2, so I will break it into two factories with limit 2. Okay, so this factor has limit 1, so this factor has also a limit 1. Similarly for this, I will break this factory into two factory also with all the factories, either of the factors with limit 1. So what I will do now is I will start at for the each index at 0, and I will check at what index, at what factor should I place it. So if I like basically chose to like basically if I chose that I should be repairing my robot at this particular index, the 2th index. So and I will check whether there is a possibility, whether there is a factory available or not. If there is a factory available, I will just remove this factory, and I will say that the current robot is fixed, and I will move to the next robot, and this robot will see the whether he need to get repaired from the next factory or not. If it does not need to be repaired from this factory, I will neglect it and move to the new factory over here. Okay, and if the robot says that yes, in this factory I will get repaired, I will move, I will say that this current robot is I have repaired and move to the new robot, and I will also move to the new factory. And this again I will check whether the robot want to be repaired from this factory or not. If the report says no, this particular this particular this particular will be cut. This particular factory will be cut, and it will move to a new factory which is present the same index. And if the robot says this factory is also does not want to be repaired from, then this will cut and move to the new index, but it will reach to the end. So basically this is not possible, so we will just backtrack and we'll say he need to be repaired from this also, this factory, in order to get repaired, in order to make all the robots repaired. So what I will do is I will make it mandatory that it will be repaired, so so at the end we will get the result. So let's see the code, and I will explain you by the code only. So this is my solution, this is my solution class. This is the function which is accepting a array list of robot containing the position of each robot. I'm also accepting a 2D matrix factory which contain the position of each factory with the limit of robots it can repair. Okay, so first of all what I'm doing is I am breaking down the factories. So first of all what I'm doing is I am sorting both the robots and the factories in the ascending order based on their position, and after that I am breaking down the factories. So I will traverse to all the factories, and I will add the factories at a particular position with limit 1 for the number of limits. So let's say there is a factory of 2, and there is a factory with a limit of 2, then I will break down into two factories with a limit 1. So similarly I have written this over here. So I will traverse over the each factory, and I will then again traverse from 0 to the limit. Basically the total I will, if the limit is 3, I will just count from 1 to 3, and I will add the position that many times. It represents that the factory is present at that particular location. And after that, what I will do, I will just pass it to the get array, get function. I've also used dp to minimize the recalculation of the previous calculated answer, so we can just take the reference from that only. I'm just initializing that dp with -1 initially. Now let's see what the function get says. So basically it is running the long which need to be returned over here. So what is it accepting? Its index of I, which is the position of the current robot. J, which is represent the position of the factory. Robot array list, similarly the array list for the factories, and this is the dp for redundant calculation, to remove the redundant calculations. So if I have calculated the distance, if I've calculated the answer, and I have just checked, I have repaired all the robots, then I will return 0 because there is no robot left to get repaired. Now I will check whether the factories have end. If the factories have end, then I will return the long value, long dot max value. Why I am returning the long dot max value? This is because my factories are in hand and my robots are still not repaired, so which is not possible. So I will just return the long value because at the end we need to find the minimum value, minimum possible value. So it cannot be, it is not possible. Then I will check dp if I have calculated the answer in the past or not. If I have calculated, I will just return that particular answer. If I have not calculated, I will calculate it. How I will calculate it? First, I will check whether what is the answer I am getting. If I will take that particular, I will take that particular factory. If I will take that, if I will take that particular robot is repaired. If I am saying that particular robot will be repaired from the current factory, then I will move to the new robot and I will move to the new factory also. But if I say that I will not pick it, I will move to the next factory and there I will repair my current robot. So I will take the maximum of uh, so got I have got here, and what I am doing is adding first of all adding the cost of moving the robot towards the factory, which is the robot.get I minus factory.get j plus got. And then I am setting the answer as the minimum of answer, comma, if I am not choosing the current factory and I have moved to the new factory, but my robot is same. Okay, so if my factories haven't, it would have written the maximum value. So in that case, my previous answer calculated, which is I have taken the current factor into consideration, will be considered. Okay. So after that, my answer will be calculated. I will store the answer into the DP, and at last I will done my answer.